Sky Clock event closing.
right. Good evening, everyone, and thanks so much for joining me. For those who don't know me, my name is Mark Gillette, and I'm a NASA JPL Solar System Ambassador. And that's kind of a fancy way of saying I'm an unpaid volunteer. Every month I do a monthly YouTube live event, something related to space and NASA. And so tonight's presentation is a little different than the ones I've done in the past. This is a virtual live star party. And so thank you so much for joining me. I'd like to go ahead and mention my next two events that are coming up soon. As you can see at the bottom of your screen, I will be doing a live NASA simulcast of the NASA Mars 2020 Perseverance rover landing on Mars. That's going to be on Thursday, February the 18th, starting at 3 o'clock p.m. Eastern Time. So if you're available, please come back and join me on my YouTube channel. Simply look for the live event, and we will hopefully walk through some exciting information about Mars 2020 Perseverance and get to see some of the live feed and information that NASA will provide about the landing. All right, so I do want to mention that I'm using all kinds of technology tonight. I've got YouTube on, I've got a broadcaster working, I've got videos playing, I have got a Zoom meeting going with my friend who's here. And so if there's any interruption in tonight's broadcast, it probably has something to do with overloading the capacity of my computer and laptop. So I apologize if we get kicked off or get us back on. Just hang in there, and we'll come right back and pick up where we left off. So thanks for joining me. I'm going to go ahead and get us set up to start doing some stargazing. I do want to introduce my friend that's here. Let's see if he is there. There he is. So you should be able to see Leonard Ward. He's on your screen right now. Leonard is my friend. He is a member of the Central Florida Astronomical Society. We live in Central Florida, not far from the Walt Disney World Resort. And so he graciously agreed to come over and to help me out tonight. So we're going to kind of bounce back and forth and take a look at some neat things in the sky. So, Leonard, can you hear me?
I do.
All right, you're on camera, so.
Oh, yeah.
All right, so thanks, Leonard, for coming and helping out. All right, so let's see. I'm going to put myself way down here in the corner and minimize myself very small and leave most of the screen for our viewing. And let's see here. I am going to start off by showing you a picture that I took of the star Capella. And that's what you're looking at on your screen right now at the moment, the star Capella. And let's see if I can right now do another, I'm going to do another shot here of the star.
I'm not seeing your desktop if you're trying to display it. All I see is your picture.
Yeah, I'm not, my computer's so bogged down it won't even turn on my monitor. All right, so right here I'm showing you another picture of Capella, and Capella is the sixth brightest star in the night sky. Right now, if you were outside looking, you would basically look straight up and slightly to your right, slightly to the east, and you would see the sixth brightest star in the night sky right now. Let me see if I can do a live view Here's a live view. I'm going to zoom in. All right, so there you go. There's a live view of the star Capella. Let me do a quick shot of that.
Deep Sky Clock event.
All right, so there you go. There's the star Capella. All right. Leonard, you ready with something?
I am.
Okay. So I'll pull you up here.
I'm not seeing your star display.
Yeah, you won't.
Okay.
You won't. All right, so I'm going to turn it over to Leonard now. And let's see if I can, can I increase the size of the screen? You do have to bear with us tonight because, at least for me, this is the first time that I do anything like this. So please bear with us with working with the technology.
Okay, you need to enable me to share screen.
Okay. Enable, let's see, how am I going to do this? Technology is an awesome thing. Share screen. How do I do that? Multiple share simultaneously. Can you do it now, Leonard?
Yes, I can.
Okay.
All right. This is the screen I want to share.
All right.
I'm doing a live stack of the Orion Nebula.
Right, and so let me mention a little bit about the Orion Nebula here. It's also known as Messier 42, M42. It is south of Orion's belt. Perhaps one of the most well-known constellations is Orion, and if you walk outside and look towards the east right now, if you have clear skies wherever you are, you can see 3 stars that are somewhatly lined up in a row. And so you would be looking at Orion's belt, and not too far from Orion's belt is the Orion Nebula that you're looking at on your screen. Hey, Leonard, can you explain what you're doing with the stacking?
Do what?
Can you explain how you're getting this picture on the screen that you're taking?
Yes, okay. I have a camera, a digital camera, attached to my telescope, which is pointed at the nebula. And the cameras bring the data into this application called SharpCap. And one of the functions that this thing has is to be able to do a live stack. What that means is the camera is taking images over and over again. If you look at this bottom right-hand corner, it shows the status of the current exposure. It just finished one exposure and it's starting another 60-second exposure. Each one of the exposures is being combined in a stack. Each new exposure is generated, it adds it into the stack. Right now I have 7 exposures in the stack. This graph here is showing the status of the image, and then the big window up here is the stack results. And what you'll see in the image, I'm going to zoom in with high resolution here. You'll see that the smoothness of the background is really nice. That's what happens when we stack. We get a nice smooth background. A single image will have noise in that background.
All right, thank you. And so I want to mention, for those who might not know what a nebula is basically a cloud of dust and different types of gases. And this is where stars are born. And I'm thinking that Leonard was getting ready to say something about that. Were you getting ready to say something about stars being born?
Well, yeah, this is a stellar nursery. There are brand new stars that are being created as we speak, and there's other stars that were born here just a few million years ago, which is really young for a star. If you look at these four stars that are real close together here, this group of stars, we've given a name to it. We call it the trapezium. And those four stars are each about, 20, 30 times as large as our sun. And they're very new, and they generate a lot of ultraviolet light. All of the other kinds of light as well, but an awful lot of ultraviolet light. And that ultraviolet light goes out into this cloud of gases and dust, and the gases get ionized by that ultraviolet light. And then when it ionizes, it starts to glow. And the red glow here is from hydrogen gas when it gets ionized. You can't really see it an awful lot here right around the trapezium, but there's a lot of oxygen that's in that area. And it is also glowing, but it looks kind of gray in here, but normally it would be kind of a cyan color. The bluer lane out here is what happens when you get light reflecting, this ultraviolet light reflecting off of that dust. It's not glowing dust, it's reflecting light is all. And we got a nice streak through here. I think that's probably one of the Starlink satellites.
Oh, yeah. I see that. It's really interesting because if you have clear skies and somewhat non-light polluted skies, you can go out at nighttime, and if you look in the right place, you will be able to make out a very a fuzzy area in the sky. You can see the Orion Nebula without the aid of a set of binoculars or even a telescope. Now, of course, it's only going to look like a fuzzy part in the sky, but it is one of very few dark sky objects that you can actually see with the unaided eye, which is pretty neat. If you have a pair of binoculars, you will be able to see a lot more than what you would probably think that you'd be able to see by looking at the Orion Nebula. So it's a really neat thing to see this time of the year. Okay, anything else on Orion?
Not offhand.
Okay, so let me see. I will go and let's see here. How will I do this? All right, I think I'm going to take us to Betelgeuse. Now, if you keep up with astronomical news, you know that last year there was a lot of talk about Betelgeuse. And the reason that there was a lot of talk about Betelgeuse is because it was dimming, and dimming significantly, a lot more than what a star would normally dim. And so there was a lot of talk to see if Betelgeuse was ready to go supernova or to explode. But scientists, after doing some additional research, discovered that it was really, from my understanding, the star was sending out some gas, and the gas was thick enough that from our vantage point, or from our perspective here on Earth looking at Betelgeuse, it reduced the amount of light that we would normally see. And so since then, it's kind of returned to the normal brightness that we would expect. So let me see if I can pull up the camera here, do a quick little shot, and bang. There you go. So there's a 1 second exposure of Betelgeuse, and Betelgeuse is a red giant, so it's an extremely large star compared to our star, the sun, of course. Let me see if I can maybe do a quick live view, and let's zoom in. All right, and see, you can actually see the color there, that it's orangey red. Do a quick shot of it. Anything you'd like to add about Betelgeuse?
It's a red giant in the news recently about being dimming very a whole lot, and they thought that it might be getting ready to go supernova, but turns out it's not going supernova. It's just a large cloud of gas that it burped out.
Okay, good. All right. You ready for another one, or shall I go?
I'm headed for Pleiades right now.
Okay, all right.
It'll take me a few minutes.
Okay, so let's see, while we're waiting for Leonard to go to the Pleiades, let's see, where is Mars? Let's see if I can find Mars. The software that I'm using here to find things is called Stellarium. And so what I do is on this software, I find what I'm interested in looking at, like Mars, and I click on it. This is connected to my telescope, and I'm going to slew, it's called slew over, and you may hear in the background some noise. That's my telescope moving from Betelgeuse and positioning itself over to the, it's kind of right up above us right now. It should be moving towards the west, of course, as the night moves on. But let's see if my telescope will be aligned when it gets there. Hopefully it will be. So just give my telescope, here it comes. You can see on your screen there is this icon here, and this represents where my telescope is in relationship to where it needs to be. And so hopefully the alignment is good. And so let me go back to the camera and let me do a shot, a single shot, and see if it comes up. No, it is not there. It is not there. All right, and this often happens because of alignment issues. So, what I can do is I can make some small adjustments here and see if I can find Mars real quick. Okay, takes a little bit here. This is not the best way of going about looking for things, what I'm doing right now, but because we're doing this live presentation, this is about the best that I can think of to try to quickly find what I want to show you. And it may or may not work. And so far it's not working. So what I'm doing is I'm using what's called slew controls, and I'm just making small adjustments to what my telescope is looking at, hoping that Mars is somewhere very close to where my telescope is pointing. And if it is, I can find Mars, and if it isn't, then I can't. Okay, let me try this one more time, and then I'll turn it over to Leonard.
Just about ready to capture my first frame of Pleiades.
Okay, so are you ready?
Almost.
Okay.
It's not finished exposing for 60 seconds yet here.
Okay, okay. Well, I have you up on the screen. I tried to find Mars and I couldn't find it.
Well, you want me to take control?
Yes, please.
Okay. I am sharing my live stack here with SharpCap. And I will have, there it is, my first image in the stack. This is the Pleiades star cluster, also called the Seven Sisters. This was, for a long time, used as an eye test to see if you could actually see all 7 of the brighter stars in here. What I'm hoping to get here yet is, it's showing up around a couple of these stars. Can you see the blue dust around this star and around this one?
Yep, I do.
As my stack gets more and more images in there, that ought to come out clearer and clearer.
So what are you taking 60-second exposures?
Yes, 60 seconds.
Okay. So the Pleiades is among the star clusters nearest to the Earth. The cluster is dominated by hot blue and luminous stars that have formed within the last 100 million years.
Getting cool out here.
Yeah, so those that are in other states, again, we're coming to you from Central Florida, south of Orlando, where we normally are in the 90s and 100% humidity, but we are having what I would describe to be a very nice winter. I'm sure many people down here would not agree with me, but right now I believe it's in the, it's probably in the 50s. So that's kind of cold for us Floridians. I love it. But it is, the temperature's going down, I think, to the low 40s tonight, which is kind of unusual for Florida. Looks like there's another satellite up in the top left-hand corner of that picture, huh?
Yes.
Yep. Darn Elon Musk. So that is that what, 2 pictures now? Or 3?
Yes.
3.
3
Yes.
in the stack.
That's good. So there's 60-second exposures. What's your ISO?
This doesn't have an ISO. It has instead a gain, and I had the gain set to what they consider to be unity. That means that for 1 ADU, it takes 1 photon to increment 1 ADU. If I change that gain, it changes how many photons it takes to increment 1 ADU. Which is kind of doing the same thing as ISO.
Okay. So how many pictures would you take in order to get what you think is a pretty good picture of the Pleiades with 60-second exposures?
I probably would be going at a lot more, like 2 full minutes or even 4-minute exposures in order to get the real dim reflection nebula that's around these stars.
Okay.
And even then, I'd still want a total amount of time to be somewhere around 2 hours.
Wow. So as I told you, I'm going to be doing that live NASA simulcast of the landing of the Perseverance rover on Mars, February the 18th at 3 p.m. Eastern Time. In March, I believe it is on March the 21st at 7:30 p.m. Eastern Time. I'm going to be doing one of my more traditional YouTube live events, and this one will be about astrophotography. It's going to be about the basics of astrophotography. So if you're available and interested in the very basics, and I want to stress basics of doing astrophotography, then join me if you're available, and you can see what it takes to get pictures like what Leonard's taking right now. I will warn you that you need to have a lot of patience to do astrophotography. You need a lot of things going for you. You need clear skies. You need, you don't want much humidity. You need to be able to set up your telescope and do your polar alignment and find your stars and do your focusing. And so it kind of takes, to me, it's short of a miracle to get a picture. You really have to know what you're doing, and then after you get the images, like Leonard said, 2, 3 or more hours worth of collecting this stuff, then you have to take and merge it all together or stack it using software on your computer. Then there are lots of steps that you go through with programs like Photoshop or others that are designed specifically for astrophotography to enhance the photos. So it's quite a bit of work to get it done, but as I was telling Leonard earlier, it's high degree of work, but it also has a high degree of satisfaction when you get something out of it. It's pretty exciting to say, hey, I was able to do that. All right, so it's on frame number 7 now, right?
Yes.
Okay. All right. So
What other places do you have? Orion, Pleiades.
And Andromeda is what I had in mind.
All right, I'm going to try to go over to Sirius.
Okay.
While you're
All right, then I'll
All right, so
head for Andromeda.
So Leonard's going to work on Andromeda, and I'm going to...
You're going to take the desktop away from me here?
No, you can keep it.
Well, you don't want people watching what I'm doing.
No, I can control it. They can't. I just minimized you. So let's see if I can take us, since I could not find Mars, let's see if I can take us to Sirius. Now, you've probably heard of Sirius, the star. You've probably also heard of Sirius XM. My assumption is that Sirius XM titled themselves that because Sirius is the brightest star in our sky, our night sky. Of course, the brightest star in our sky would be our star, the sun, but we're talking about other stars, so Sirius is the brightest one. So hopefully my alignment will be better for Sirius than it was for Mars. So you might hear my telescope slewing over to where Sirius is located. It looks like it's headed in the general right vicinity. But boy, that doesn't look good at all. Oh, let's see.
Sirius is a double star, but it's very close, and there's a lot of difference between the brightness.
Okay. And
If you've got a real good focus on it and whatnot, you might be able to pick out the pup.
all right, good. So as you may have heard Leonard said, say that Sirius is a double star, and scientists believe that 50% or more of all of the stars in the universe are double star systems. In other words, there's not one star, but there are two that are gravitationally linked to one another. And Sirius happens to be one of those. So right there, you can see a 1 second exposure picture that I took of Sirius. And let's see if I can go to a live view right here. This is a live view, and I'm going to zoom in. Okay. Too far away for us to see the other star. Take a quick shot of it.
Exposure finished.
Okay, but so it looks like one star, and if you were to go outside and take a look at it from wherever you are, it definitely looks like one star from our vantage point, but indeed it is a two-star system. Okay. Anything else you can think of about Sirius, Leonard?
Seriously?
Seriously.
Yeah, like I was saying, it is a double star, and the reason that you can't see it naked eye is that it's such a close double star that they didn't even know it was double until they started pointing some of the higher, not higher magnifications, but some telescopes at it that had a real clear view and could magnify enough to be able to separate the two stars.
Okay.
And like I was saying, the second star is a whole lot dimmer than the primary.
Okay.
They call it the pup.
The pup.
Yep.
Okay.
Because you got Sirius, the dog star, and then the B star is referred to as the pup.
Okay. All right. So there you have Sirius. So if you go outside and you have clear skies, look to your east, and it will be slightly to the south at about 45 degrees from the horizon. You'll see a bright star, and that will be Sirius. And then if you keep following Sirius straight up, you'll see Orion's belt that I spoke of earlier. Right to the right-hand side of Orion's belt, you'll see the fuzzy patch in the sky, which would be Orion's Nebula. And if you go to the left of that, you'll see a star that looks red, and that's Betelgeuse that we spoke of earlier. All right. Are you on Andromeda?
I am on Andromeda, but I am not stacking yet.
Okay. All right.
Just now opening up the stacking application and going to start taking images. I'll start with just 30 seconds probably.
Okay. While Leonard is pulling Andromeda Galaxy up, Andromeda is the closest large galaxy to our own Milky Way galaxy at about 2.5 million light years from us. Don't forget about the chat. If anyone has any comments, any questions, feel free to put those in the chat. And I have my husband Spencer who is monitoring that. And if anything comes up, he can pass that on to us because we're very busy maneuvering our telescopes around. So I'm not really paying attention to the chat box.
I have an image.
Okay.
Not very good yet. I'm going to go to 60 seconds.
Okay. So Andromeda, again, the largest, nearest galaxy to our own, about 2.5 billion light years away, million light years away. Keep in mind that when we talk about 2.5 million light years, that means that it took 2.5 million years for the light that we are looking at now to come to our eyes or to our cameras. Okay, so we're not looking at Andromeda like you might be looking at a book that's in front of you. We're looking at this stuff it's kind of like looking back in time. We're not seeing it as it is at the moment. We're looking at it as it was a long time ago because these things are so incredibly far away. So that's pretty cool, and shows us how far things truly are when we have to not talk about things are millions, billions, or trillions of miles away, but to go to a whole new standard of measuring and look at it through how fast light travels. Light travels at roughly 186,000 miles in 1 second. Okay, so light travels really, really fast, but yet it still takes millions of years for that light to travel from some of these very long places or distances that we're showing you. How's the 60-second one coming up? So what Leonard's doing is he increased his exposure time from 30 seconds to 60 seconds. And when you're taking pictures or images of deep sky objects, a couple of the things that you have to keep in mind is that you want to get your exposures as long as you can. Because if you're only taking, like what I've been doing with the stars, a 1 second exposure, that's not going to work when you try to take a picture of a galaxy. It works when you take a picture of a star because the star is so bright. The other thing is when you take these images, you have to take a whole bunch of them, as mentioned earlier. You can't just take one single picture and bam, there you go. You have a beautiful picture of the Andromeda Galaxy. You have to take hundreds of pictures with long exposures and then use that software I was talking about earlier, the stack or merge
What's going
them all
on
together
here?
to get the beautiful pictures that you often will see in magazines or online. All right. Share your screen anytime you want.
I think my application crashed.
Uh-oh. All right. We may be running into some little technical problems here, but that's okay. So while Leonard's working on that, I will take us to our next location. Let's see here. Come on. Artificial satellite. I'm trying to find Polaris. Polaris, also called the North Star. There we go. Now let's see if my telescope will find Polaris. When you do astrophotography or any basic viewing of different sky elements, you have to do what's called a polar alignment. And in the northern hemisphere, we use the northern star or Polaris to align our telescopes before we do anything. And so Polaris is the star that we use to do that work. All right, let me see if I can get a picture of Polaris. No. Let me see something here.
Okay, I have an image.
Okay. All right. Well, I can't pull up Polaris, so I'm going to let Leonard take over, share his screen, and we'll take a look at an image of the Andromeda Galaxy. Whoops, where'd you go, Leonard?
I'm coming. There it
There
is.
you go. There. Very nice.
Okay, now that's got one image in it. We've got Andromeda Galaxy, the big guy here, and then this is a satellite galaxy going around It's actually orbiting around Andromeda. This is referred to as M110. And there's another one around here somewhere, as I can't see it just yet, though. It's usually a little bit closer in to the middle of Andromeda.
One of the neat things about Andromeda is if you have dark enough skies in the area that you live in and not too much light pollution, and you know where to look, you can actually look at Andromeda with an unaided eye. In other words, you don't need binoculars, you don't need a telescope. Now, what are you going to see? You're going to see a little fuzzy spot in the sky, so don't get too excited. And the reason for that is because our eyes cannot pull in enough light to be able to see the galaxy as it truly is. So that's why we have to do this imaging. We take lots and lots of pictures, collect lots and lots of light, and then use those pictures, stack them all together to bring out all the light. But it is one of those objects that if you know where to look and you have dark enough skies, you can actually see it without binoculars or a telescope.
And when you're looking at it naked eye, what I have on the display here is about all that you get to see.
There you go. But that's a really, really neat thing to be able to see with your, to me, I go outside and look at that and think, wow, that is a galaxy. That is a collection of millions and millions of stars that are all gravitationally linked to one another. Right there in the middle, you have, I believe Andromeda has a black hole, right?
Yes.
So it would be right there in that area. I know a lot of you who watch, you often ask about black holes, and so the Milky Way galaxy has a black hole called Sagittarius A. Andromeda has a black hole. But here, you're just looking at millions and millions and millions of stars, again, that are all gravitationally linked to one another. And, in the mid-1990s, scientists discovered exoplanets. And an exoplanet is a planet outside of our solar system. Of course, we have 8 planets in our solar system, and so we simply call them planets. But when they're located around other stars, we call them exoplanets. And scientists today believe that, on average, every star has at least one exoplanet, probably more. So that means there are probably a whole lot more exoplanets out there than there are stars. Then the next thing that comes up is, well, how many of those exoplanets are in what's called the habitable zone around their star? What does that mean? That means that it has liquid water. And when we go out looking for life elsewhere, we what's called follow the water. Life as we know it depends on water. And so if there are planets that are in the habitable zone around their star,
Deep sky clock event closing.
There is a chance that it could support life. So when you think about all those millions and millions of stars just in that one galaxy right there, who knows what might be there looking back at us, wondering, gee, is there life out there? Is there intelligent life out there? It really gets you thinking, and it's quite intriguing and amazing. And so I think Leonard was able to find the other satellite galaxy there, right?
Right. Andromeda is referred to as M31. This guy is M32 and M110.
Okay. So 2 satellite galaxies right here that are gravitationally linked to the larger M31 or Andromeda galaxy. They look very small, but these are very, very big. Everything in the universe is very big, very, very far apart. It's expected, how many millions of years? I don't know. 10 million, 10 billion? What is it, 10 million years? That the Andromeda galaxy will be colliding with our galaxy, the Milky Way galaxy. Now, you and I don't need to lose any sleep over this because we're going to be gone. But even if there is life still here on Earth at the time, which there probably won't be because well, let's see here. No, our sun is about halfway through its life. It's a 10 billion year lifespan. It's about 5 billion years, so it's got 5 billion. Do you know how long it will be until Andromeda collides with us?
I'm sorry, I'm getting an echo over here.
Do you know how many years it will be until they say Andromeda collides?
It's like 5 million.
Million or billion?
Billion.
Yeah.
No, wait, it's Andromeda's 2.5 million light years away.
Right.
Okay, 5 million.
5 million. So, okay. So 5 million years, whoever happens to be living on Earth at the time will get to experience this.
By the way, that also happens to coincide with when the sun is supposed to go red giant.
A red giant, yeah. It's going to become a red giant before it officially dies. Now, you might think, okay, it's going to be a big mess when one galaxy collides with another one. Actually, it's not going to be a big mess. To show you how big space is, there's so much room between the stars that make up our galaxy, the Milky Way, and the stars that make up the Andromeda galaxy, that when they come and merge together, very few will actually collide with others. Very few. Because there's so much space. That's pretty neat. All right, so we're on frame number 5. Let's see.
Yes.
So this is basically the process that you go through to do astrophotography. He's on frame number 5. He's taking, I believe these are 60-second exposures?
Sorry?
60-second exposures?
Yes.
Yep. So here he would want to go through and take, 2-3 hours worth of data and then use that software I was talking about, stack them and merge them, and then use Photoshop and other software to enhance the picture. So it's quite involved. But here you can already see right here in this picture, you can see a dust lane. Just a whole bunch of dust. And so now he's on number 6.
Trying to find a color balance.
Okay. And so
None of them look good.
so as this goes up, as he takes more and more frames or images, this picture will continually get better and better and better.
Well, it gets better in the sense that the background around these stars away from the galaxy, that's what I was looking at the image a lot closer in detail. And you see how grainy it is when you look at it real close up. Okay, that's what the stacking gets rid of, is this grain. When it gets rid of that grain, what's part of our information that's mixed in that grain gets lost. But when we get rid of the grain, that information starts popping out like it is over here. So that's why we always stack a whole bunch of images together, is it reduces the noise in the image so that we can bring out the detail of the data that we actually looking to find in there. Also, the kind of stacking that we use would eliminate these lines. The live stack here is just doing a pure average. We use some much fancier combining methods in order to do it when we're really being serious about it. Also, if you notice this this circle here, this is caused by dust that's on my optics. Okay? It causes a shadow in the image, and we take what's called calibration frames, specifically a flat calibration frame, to try and make this go away as best we can. Also, I've got these black spots that are showing up in here. Those are dirt that's right on the sensor. I got to get in there and clean this guy up, get rid of that stuff before I start doing anything serious again.
All right. Well, we've got about 8 minutes left. Do you think we can, is the moon,
I guess the moon is behind
The moon?
the moon is behind the tree.
Ooh, okay. Oh, it's behind a tree? It's not going to work good that way. No, not at all.
let me see if I can pull up the moon with mine. Let's see here.
You got a tree trunk in the way.
All right, let's see if I can get a picture here. It is low in the horizon, so there we go. You can see there are some tree limbs here because I have a tree that my
Yeah, you're looking around a tree trunk.
yep. But it won't be up over the top of the tree for probably another I don't know, hour or so. So we only have
Well, it's going to take 2 hours to get above
that tree.
closer
Okay.
tree.
Yeah. So that's about the best I'm going to be able to show you. I think it's a full moon tonight, or pretty close to a full
It's
moon.
just past.
Just past a full moon. All right. So, well, we are almost to the end of our program. I'd like to thank Leonard so much for coming and taking his time to spend with us
I
tonight.
enjoy it.
Good. If anyone has any questions, please make sure that you just pop them in the chat here real quick. I'm trying to pull up my chat. I'm not seeing anything. Try something else here. There we go. Oh, so I have a friend, Richard, works for the Orange County Library System, who's attending. So thank you, Richard. Hope you're having a good evening. So I think we're going to go ahead and call it a night. I hope that you enjoyed tonight's presentation, a little different than the ones I've done in the past. Again, I want to thank Leonard so much for coming. He was the person that really helped me to get into astronomy and astrophotography, so I'm very grateful to him and for his friendship. Don't forget to join me. Come back here and join me on my YouTube channel on Thursday, February the 18th at 3 p.m. Eastern, where we will be watching a simulcast of the NASA Mars 2020 Perseverance landing on Mars. So that should be very exciting. So thank you so much for joining us tonight, and have a wonderful rest of your evening. Thank you so much.